Welcome back. In this video we're going to have a look at how we can do multiplication in binary. Now looking at the first example here, we have 10 times 2, and then underneath it over here we have the equivalent binary numbers, so 1010 multiplied by 10. Looking at these decimal numbers here, if we wanted to do this arithmetic, we can simply say 10 times 2 is equal to 20, and that's pretty simple. And likewise, since we know that 1010 is 10 and 10 is 2, we could simply write the binary equivalent of 20 underneath here as well. But we want to know how to do all of this purely in binary. Now, before we go into the binary operation, let's have a review of how we do this a long way in decimal. So if we're going to multiply 10 and 2, what we do is we write 10 like so. Then underneath the 10, we write the 2. Then we put a little bar underneath both numbers and we go for some multiplication. Multiplying this out, we first look at 0 and 2 and we say, what's 0 times 2? And we know that's 0. And secondly, we go across and we go, what's 1 times 2? And the result of that is 2. So therefore, the result of 10 times 2 is 20. Like we've got over here. So nothing too difficult. But now let's have a go at doing this with binary. So we'll get our first number, 1, 0, 1, 0. Then we'll get our second number, 1, 0. And we're going to set everything up like we did in the first round. So we're now going for some multiplication. To multiply this out, we go the first two numbers, 0 times 0, it's nothing. 0 times 1 is also nothing. 0 times 0 is nothing. And then 0 times this far 1, that's also nothing. So nice and simple there. Now we have to shift because we're going from this digit over to this digit. So we've got to shift by 1. Now we're going to go 1 times 0. That's nothing. 1 times 1. Well, if it's 1 times 1, we know that's 1. 1 times 0, that's nothing. And then finally, 1 times 1 is 1. Alright, nearly there. Next step is we draw another bar, and we're going to go for addition. Adding these all up, we get 0 and 0 is 0, 0, 0 is 0, 0, 1 is 1, 0, 0 is 0, and nothing and 1 is 1. So therefore, the binary equivalent to this is 1, 0, 1, 0, 0. Very interesting. So this is our interpretation for, or this is the binary representation of 20. So nice and straightforward. Let's have a look at example 2 now. We have 25 multiplied by 10. So let's do the decimal arithmetic first. So we'll go 25 to go the bar, go the multiplication. 5 times 2 is 10. So we're going to carry the 1. 2 times 2 is 4. Plus the 1 is 5. Like so. So our result is 50. Therefore, we're going to expect the value of 50 when we do this in binary now. So we're going to go 1, 1, 0, 0, 1, and then our second number is 1, 0, like so. Set up the multiplication, and let's go for it. 1 and 0, that's nothing. 0 and 0, nothing. 0, 0, nothing. 0 and 1 is also nothing, and 0 and 1 is also nothing. So pretty easy line to calculate there. Now we're done with this 0 here. Let's go for the 1. So we're going to put a space. Then we're going to go 1 and 1. That is simply 1. 1 and 0. That's 0. Next one is also 0. 1 and 1. That's 1. And 1 and 1 is 1. Now we draw a line like so. And we go for arithmetic. We're going to add. So we're going to go 0 and 0 is 0, 0, 1 is 1, 0, 0, 0, 0, 0, 1 is 1, and finally nothing and 1 is 1. So our final result is 1, 1, 0, 0, 1, 0, like so. So pretty straightforward. One thing to pay attention to is notice the size or the width of these numbers here. So this first digit or these first numbers, 25, it's 1, 2, 3, 4, 5 bits wide. The 2 is 2 bits wide. And the resultant value is 1, 2, 3, 4, 5, 6. So it's 6 bits wide. We've gone from 5 over here to 6 over here. Interesting. Maybe we'll see a pattern emerging later. Alright, let's go for example 3 now. Alright, 105 multiplied by 3. Now things are getting pretty interesting. Grabbing the decimal numbers, we'll go 105, like so, and then we'll put the 3 underneath. We draw the bar, and we go for times. 5 times 3 is 15. Put the 5, carry the 1. 0 times 3 is nothing, plus the 1. So that's a 1 down here. And then 1 times 3 is 3. So what we're expecting is a resultant value of 315. Now let's do it in binary. Do we have enough space? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. Yeah, we should have plenty. So we go 1, 1, 1, 0, 1, 0, 0, 1. Then 1, 1, 1 for our 3 down here. Now let's go for times. Going in for times, we're going to go 1 and 1 is 1, and 0 and 1 is 0. So what you probably noticed in the first two is that when you have a 1 in the bottom here, it's just going to repeat all of this number over here. So all I'm going to do is copy down the top number in the first line like so. That's done. Now I'm going to cross that number out and I'm going to shift by 1. Then I'm going to repeat the process. 1 and 1 is 1. 1 and 0 is 0. 1 and 0 is 0. And 1 is 1. And perhaps what you've started to notice again is we're just repeating this pattern here, but we're shifted over by 1. So what we can do is we can just write 0, 1, 1 like so. And therefore our job is done. Now we're going to go to the third digit here and we're going to shift by 2. Going 1 and 1 is 1. 1 and 0 is 0. And lo and behold, we're following the pattern once more. So rather than going through every single digit, I'm just going to see what I see here and then repeat it down here but shift it across. So we're going to go 1, 1, 0, 1, 0. And our job has become that much easier. Now I'm going to get a line and draw it across like so. Alright, here's where things are going to get tricky. We're going to try and add across 3 different lines. So first one, we're going to go 1, 0, 0. So that's 1. 0, 1 is 1. And then 0, 0, 1 is 1. Next line, 1, 0, 0. That's 1. 0, 1, 0. That's going to be 1. Here's where we're going to run into some interesting arithmetic. We're going to go 1, 0, 1. That's going to be 1, 0. So we put the 0, carry the 1. Now I've got 1, 1, and 1. So that's going to be 1, 1. Put the 1, carry the 1. 1, 1, 1. That's going to be 1, 1. Put the 1, carry the 1. Now we've got 1 and 1. That's going to be 1, 0. So put the 0, carry the 1, like so. Therefore, our final result is going to be, can't fit it in all these boxes, so I just have to write it compressed. 1, 0, 1, 1, 0, 1, 1, 1, 1, 1, like so. And let's just verify in the program over here whether we've done it right. So convert binary to decimal. Then we're going to go 1, 0, 1, 1, 0, 1, 1, 1, 1, 1. Slightly off. Let's see what we've done wrong. Alright, found out where I've made the mistake. And it's really silly. This 3 over here, that's not 3. That should be 7. 1, 1, 1 is actually 1, 1, 1 is actually 7. So therefore, if we amend the arithmetic here, put a 7 in there, redo this guy here, 5 times 7 is 35. Carry the 3. 7 times 0 is 0 plus the 3, and then add the, or 1 times 7 is 7. So 735 should be our actual result. And therefore, if we go over here, we get our final result is indeed equal to 735. So interestingly enough, I actually did the binary arithmetic correct, and I did the decimal arithmetic incorrectly. Anyway, good thing to learn by. Good thing I checked with the binary.